Today, you'll learn how to apply what you know about area of circles to finding area of sectors of circles. A sector of a circle is technically defined as a segment of the circle's area bounded by an arc and two radii. The word bounded in this definition really just means contained. So when they say it's a segment or a piece of the circle's area bounded by an arc and two radii, they mean it's a section of the circle that's contained by an arc and the two radii that go from the end of the arc to the center of the circle. So really, this definition is a fancy way of saying that a sector of a circle is a pie slice shape. Now, when you're naming sectors, the one difference from naming sectors and arcs is first, there's no arc symbol because it's not just the arc, it's a whole pie slice we're talking about. And secondly, you have not only the endpoints here and here in the name, but in between you have the tip of the pie slice, whatever the center of the circle is named. So here we would name this sector MON. Now, finding area of a sector is really based off of first finding area of a circle. And as you know, that's pi r squared. All you have to do to find the area of just one sector of a circle is do n over 360 times whatever answer you got for area of a circle. Remember that n really just means how many degrees the arc at the edge of the sector makes over the center of the circle. So really, this is going to be identical to what you did last class, except instead of being n over 360 times circumference, it's n over 360 times area. Let's walk through one together. First, go ahead and find the area of the circle. Area equals pi r squared. You should get 16 pi centimeters squared. Area of the sector CBD. Okay, so sector CBD, let's find it. Sector CBD is this pie slice. So first off, just like last time, you're going to find the degrees of the measure of that section of the circle. Okay, 90 degrees, and put that over 360. 90 over 360, go ahead and simplify. 90 over 360 simplifies to 1/4. So what that means is that the sector is 1/4 of the circle's area. So now you take that n over 360 answer and you multiply by what the total area is. So now you have 1/4 times 16 pi. This time when you multiply, it simplifies to a whole number. And then your final answer, don't forget your units. So your answer is 4 pi square centimeters. Pause the video here and try question 2. First, you found the area by plugging in the radius. Then you made your n over 360 fraction, 84 over 360. Now, a quick note about simplifying fractions like this. I don't always immediately look at this and figure out what the greatest common factor would be, the largest number that would divide both 84 and 360. In this case, the largest number that divides both is 12, but I might not notice that right away. So it's okay to simplify in stages to first notice, oh, I could divide them both by 4, look at the result, oh, I could divide that by another number. You get the same answer, it just takes more steps if you don't see the greatest common factor right away. So I know that the area of sector RST is 7/30ths of the whole area. So I do 7 over 30 times 81 pi. I can either multiply straight across and then simplify, or I could save myself time on the simplifying by cross-canceling before multiplying straight across. I can notice both 30 and 81 can divide by 3. Simplify and then multiply straight across. Notice how you leave all your answers in terms of improper fractions with circle problems if it's not a whole number. So leave your answer in this format, 189 pi over 10, and don't forget your units. Pause the video here and finish the rest of the front page on your own. Go ahead and check your answer for question number 3. A quick note about question number 3. Notice how they're asking for the area of the shaded sector. So if all the rest of the circle is 240 degrees, you'd have to do 360 minus 240 to figure out the measure of the sector you actually care about. And that's how you get that section would be 120. 360 minus 240. Go ahead and check your answer for number 4. Now, there's one last thing you need to learn about in this lesson, and that's how to find the area of a circle segment. Now, a segment is an odd word in math in that it has more than one definition. The most common one, as you know, is a line segment. A circle segment is completely different. In a circle, a segment is a part of the circle that's bounded or contained by an arc and a line segment that joins the endpoints of that same arc. So it makes this little sliver of a shape. You could kind of think of a segment as the pie crust on your pie slice. To find the area of that segment, that little sliver at the end of your sector of the triangle, you would find the area of the sector and then subtract the area of the triangle piece of that pie slice. So you have just the sliver at the edge left. Let's walk through one together. Step 1 for number 5 is to find the whole sector area. So go ahead and find the area of this pie slice. 90 degrees here, you got this. (90 over 360) simplifies to 1/4. The whole area of the circle, pi r squared, would be 16 pi. So it'd be 1/4 times 16 pi. The sector area would be 4 pi. That's step 1. Next, we need to find the area of the triangle that's under the circle segment we're solving for. So if we zoom in on that triangle, it's a right triangle. And because the radius is 4 here, then all the other radii would have to match it. So if this side is 4, this side is 4 in that triangle. As you guys recall, triangle area is 1/2 base times height. For this triangle, because it's a right triangle, the side is the height. So 1/2 base times height would be 1/2 of 4 times 4. And you would get 8 for the area of the triangle. Step 3 is to take the sector area and subtract the triangle area to find the area left over at the edge of the sector, that little pie crust section. Put that in a calculator, and you're going to get around 4.57 square meters for the segment area. Quick note, because you're doing 4 pi minus 8, and they're not like terms, you're going to do 4 times 3.14, or even better, 4 times the pi button on your calculator, and then minus 8. Let's walk through one more together. Pause the video here and find the sector area, step 1. You know that in this semicircle, if the section is 60, if I do 180 minus 60, the missing piece is 120 degrees. So 120 is the measure of the section I care about. So 120 over 360 simplifies to 1/3. They're saying the whole diameter of the circle is 8, so the radius is just half of that. Radius is 4. So 4 squared is 16, so pi r squared is 16 pi. 1/3 of 16 pi, 16 pi over 3 for the sector area. Step 1 complete. This is where it gets a little bit weird, finding the area of this triangle, because here's the deal. We don't know the height of the triangle this time. Neither of the sides work as the height because there's no right angles involved. However, back in section 10.5, so you could reference the back page of your 10.5 notes for this, you learned how to find the area of a triangle that doesn't have a height. And your equation for that is 1/2 times side times sine of the angle between the two sides. And we have all that information. So we plug in 1/2 times 4 times 4 times sine of 120 degrees, and you get around 6.93. Now you can subtract sector area minus triangle area. Pause the video here and try the last one on your own. Go ahead and check your answer. Great job, everybody. Don't forget to take a picture of both sides of your notes and turn it in on Schoology.